Today we're looking at lessons in Activity 19, Exponent Rules. And we're just kind of going to go through these a little quicker than normal, since a lot of these rules are fairly easy to understand. You just kind of got to memorize or know what they do. Okay, so let's look at the basic exponent properties first. And let's come on down to this chart on number 6. So we have the original product. We're going to be looking at multiplying exponents. Okay, 2 to the second power times 2 to the fourth power. Well, 2 to the second power means you're multiplying 2 times itself twice. 2 times 2. And then 2 to the fourth power means you're multiplying 2 times itself 4 times. And then you multiply both of them together, you have it right here. 2 times 2 times 2 times 2 times 2 times 2. And so you end up with it being 2 to the sixth power, because now you have 6 2's being multiplied together. Well, the key trick to this is that when you're multiplying exponents with the like base, with the same base number, and remember, base is this number underneath the exponent is the little number at the top. When you're multiplying like bases, you can really just, the trick is to add the exponents. 2 plus 4 is 6, and you keep the same base number. So, like here, 5 to the third power times 5 squared, 5 to the second power, well, that's 3 5's being multiplied together. Times 2 5's being multiplied together. I just messed that up just a second. So 5 times 5 times 5. Times 5 times 5. And when we look at it out in this expanded form, it's easy to see that now we have 5 5's being multiplied together. So that would be 5 to the fifth power. But as we said, the little trick is multiplication is just repeated addition. So it's 5 times 5 times 5 times 5 times 5. We now have 3 plus 2 equals 5. 5 to the fifth power. You can just add the exponents. So x to the fourth power times x to the seventh power. We can skip ahead and just kind of know that's going to be x to the 11th power. So when you're multiplying like bases, you really just need to add the exponents. Okay, we could write out 4x's times another 7x's, but in the end, it's going to be x to the 11th power. A to the sixth power times a to the second power, well, that's just going to be a to the 8th power, 6 plus 2. We have 6 a's times another 2 a's. That's a total of 8 a's. So remember, the multiplication, the product property for exponents is add the exponents when you're multiplying like bases. So if we looked at number 7, if we wanted just a generic formula for this, well, what a times a to the m power times a to the n power is going to be a to the m plus n. You're just going to add the exponents. If I wanted to write them as a single property of a to the 3/4 times x to the 5/4, x to the 3/4 times x to the 5/4. Like bases, they both have x as a base. That's the important part. We can't really combine things that do not have similar bases. Well, 3/4 plus 5/4 is 8/4. So that's x to the 8/4. And if you reduce, you can reduce it, even your exponents. That's going to be 8 to the second power. 8 divided by 4 is 2. So there we go. That's the rule for product of powers property. You basically just add the exponents for like bases. All right, now we're going to look at the quotient property. Okay, let's zoom in just a little bit because these are getting kind of small. The quotient property is when you're dividing like bases, okay? You can see that they've already written it out for you to show you what's actually happening. You have 2 to the 5th power, which is 5 2's being multiplied together, divided by 2 to the 2nd power, which is 2 2's being multiplied together. Well, when you actually write it out, you can see that these cancel each other. One on top cancels one on bottom. Another one on top cancels another one on bottom. And all you're left with is 3 2's left, so that's 2 to the 3rd power. Well, the easy rule for this to think about, the trick, is that when you're dividing like bases for exponents, subtract the exponents. 5 minus 2 is 3. So it'd be 2 to the 3rd power. For like this one, we could write out 8 5's on top and 6 on bottom. 6 of those would cancel from the bottom and the top, and you'd only be left with 2 left, which means you just subtracted the bases. 5 to the 8 minus 6, basically. And it's going to be 5 to the 2nd power. Okay, similarly, for a to the 3rd divided by a to the 1, well, with dividing property, we're going to do 3 minus 1, which is a squared. Okay, so when you're dividing exponents with like bases, you can just subtract the exponents, and that will leave you with your simplified version. Do remember, though, that a to this first power, most of the time you're just going to write a. Okay? If you just see something written, 5, for example, if you need to know what the exponent is on there, it's a 1, 5 to the first power. Okay? We just don't write 1 on top of stuff most of the time. Okay? You're usually going to just see this a and not a with 1 on top, a to the first power. We just call that a. So if you don't see an exponent on top of a variable or on top of a number, assume it is 1. And so let's look at this last one. X to the 7th power divided by x to the 3rd power. Well, that's x to the 7 minus 3, which is x to the 4th. And we could just list it out, 7 x's divided by 3 x's. 3 of those will cancel on top and bottom, and you're left with 4 left over. But just kind of know the trick is to subtract exponents when you're using quotients. The quotient property, as long as it doesn't come out to be 0, you can just say a sub is m minus n when you're dividing exponents, as long as it doesn't come out to be 0, because that's a whole different property, which we'll probably get to in just a second. Okay, so let's look at this one real quick. A to the 11 over 3 power divided by a to the 2 over 3 power. Well, quotient rule says I'm going to subtract those. 11 over 3 minus 2 over 3. Okay, well, 11 over 3 minus 2 over 3 is 9 over 3. So a to the 9 over 3. And we can reduce that because 9 over 3 is 3. That's really just a to the 3rd power. Okay, dividing, subtract the exponents. When we multiplied up here, we added the exponents. When you divide similar bases, like bases, you subtract the exponents. Okay, and just to be sure, if they have coefficients, remember those numbers are not part of the exponents. The exponent 4 is over the x, not the 5. So we're not using the same rules for those things. These are just regular numbers. 2 times 5 would be 10. And then x to the 5th power times x to the 4th power. Well, 5 plus 4 is 9, so it would be 10 x to the 9th power. Okay? So remember, the numbers out in front are called the coefficients. If you remember that word from previous times in math, it was the number that's being multiplied times a variable. The number is basically out in front of the letters. Those are coefficients. They're not actually under the exponent right there. So they're not part of this rule. The exponent rules only apply to the like bases. There's an x right here, there's an x right there. We can combine those bases since they're being multiplied by adding them. Exponents. So let's just see 1, 2 quick examples so we can move on. Let's look at A right here. 4xy to the 4th times negative 2x squared y to the 5th. Well, let's multiply our coefficients since they don't have anything else to do with. Those are the like terms we're going to combine. 4 times negative 2 is negative 8. All right, let's do our x's next. We have x times x squared. Remember, we assume that there's a 1 over anything that doesn't have it specifically written. So it's really x to the first power times x to the second power. Add those together, it's x to the third power. Y to the 4th power times y to the 5th power. Add that together, that'll be y to the 9th power. Okay, again, I'm going sort of fast on these because it's not actually that difficult of a rule. Multiplying, you add the exponents. We'll look at C since that's a little combination. We have 6y to the 3rd power divided by 18x times 2xy. Let's take care of all the numbers first. 6 over 18 is 1/3. 1/3 times 2 is 2/3. Okay, we did all of our coefficients, the numbers in front. We got rid of those first. Then let's do the next one. Y to the 3rd power times 1y here. So that's really 4y. But y to the 4th power. I'm sorry. We have x multiplied times over x in the denominator. So we're going to subtract the numerators. Subtract the exponents. X to the 1st power minus x to the 1st power. So that'll be x to the 1 minus 1, which is 0, which is a rule that they just said it shouldn't happen, but this is what does happen when it does happen. X to the 0 power is 1. And 1 times anything is just that number. So 2/3 y to the 4 times 1 is 2/3 y to the 4th. Okay. X to the 0 power is 1. Anything to the 0 power is 1. As I said, we'll get to that rule in just a second because they just had it right there. Okay. It doesn't matter whether it's 2x cubed. If that whole thing is to the 0 power, it's equal to 1. Anything to the 0 power is equal to 1. But that's also easy to do since you just multiply everything times 1 and it ends up being that same number. So it sort of just fades away. Think of it like that. All right. So let's go ahead to lesson 2. Talking about those negative and 0 powers. Okay, well, I just told you about the whole 0 thing. Anything to the 0 power is 1. I'm not sure how much more we could tell you about that, but we'll see when we get to it. So let's look at these. They did the subtraction, okay? They did the division. They subtracted their exponents. 2 to the 5th divided by 2 to the 8th. That'd be 2 to the 5 minus 8, which is 2 to the negative 3. Okay, 5 to the 3rd divided by 5 to the 6th is 5 to the 3 minus 6, which is negative 3. Okay, it's the same rule we've been doing, but we're going to tell you what the negative numbers actually mean when they're in the exponent in just a second. A to the 3rd divided by a to the 8, well, that'd be 3 minus 8. That'd be a to the negative 5. And then x to the 4th divided by x to the 10th, that'd be the 4 minus 10, which is negative 6. Well, what that means, and you can see it up here, is that negative exponents are on the, how do I say this? Are they reciprocal? Okay, if you take the reciprocal of a negative exponent, that's where it's the positive one. So when we did this first one, we had 5 2's divided by 8 2's. We canceled everything out. We were left with 3 2's just on the denominator. So we said 1 over 2/3. Okay, that's a negative exponent when we just flip it over to the -3. Or the other way to think about it is if you want to get rid of negative exponents, flip it over and it becomes positive. Take the reciprocal and it becomes positive. So if it says a to the n, well, that's a to the negative n. As long as a is not 0. We don't want to have a 0 situation, because that's a whole another one rule, which we've already said is a 1. So it's not that difficult, but let's not focus on it quite yet. So let's look at these. 2 to the 4th power divided by 2 to the 4th power. Well, 4 2's divided by 4 2's is 1. 4 minus 4, uses the quotient property. 4 minus 4, 0. 1. Anything to the 0 power is 1. And this is just showing you why that works out. 5 to the 6th power divided by 5 to the 6th power. That's 5 to the 6 minus 6, which is 0. 5 to the 0, which is 1. It would have 5 6's on top. I'm sorry. You'd have 6 5's on top and 6 5's on the denominator. And that would cancel out, because when you divide this top same number, let's say 3 divided by 3, you still get 1. So a to the third is a to the 0, which is 1. So basically the 0 power, anything to the 0 power is 1. As long as we don't say 0 to the 0 power. So let's look at these real quick. Because again, these properties are not actually difficult. It's just if you've never seen them before, you just got to kind of learn the tricks. 2 to the -3rd power, take the reciprocal. It's now 1 over 2 to the +3. 2 to the 3rd power. So negative exponents, just take the reciprocal. Flip it over, basically. 10 to the 2nd power divided by 10 to the -2nd power. Well, the quotient rule says we subtract our exponents when we divide like bases. So that's 2 minus -2. And if you subtract a negative, you're actually adding. So that's 10 to 2 plus 2, which is 10 to the 4th. All right. 3 to the -2 times 5 to the 0. Well, 5 to the 0 is 1. So it's just 3 to the -2. And then we don't actually want to look at negative exponents. So I'm going to flip that over, and it's 1 over 3 squared. -3.75 to the 0 power, 1. Anything to the 0 power is 1. All right, so let's keep going. We can do commutative property. That just means that we can move things around so that they're next to each other to make them easy to work with. Put all of our x's next to each other, the y's next to each other, the z's, the numbers. Okay, the commutative property. That helps us keep track of everything if you want to do it that way. So if we want to simplify and write without negative powers, we could put everything together, or we can just kind of do it in our head. But let's see. 2 times 5 is 10. We'll put our numbers together first. A squared times a. Okay, well, that's multiplying, so we're going to add the exponents. 2 plus 1 is 3, a to the 3rd power. B to the -3 times b. So that's -3 plus 1, which is -2. B to the -2. Now we actually don't want any negative numbers, so we're just going to rearrange this again. 10 is fine. A cubed is fine. B to the -2, we need to flip over and make it b to the +2. It's just now in the reverse section, so it's in the denominator. Anything to the 0 power is 1. I can just look at that right there and get that. Let's look at b. 10 divided by 5, we'll do the numbers first, 2. X squared divided by x to the -3. Well, subtract when you're dividing. That's 2 minus -3, which is actually 2 plus 3, so that's x to the 5th. y to the negative fourth minus negative 1, which is y plus, y to the negative 4 plus 1, which is y to the negative 3, but we don't want that, so we're going to flip it over, and it now goes on the bottom, y to the positive 3. Okay, as I said, we're kind of going fast, but I think you can follow along with this. Let's see, simplify without negative exponents. Again, take the reciprocal. Z to the negative 3 is going to be 1 over z cubed. 12 times all this, that's just going to be 12 times 1, because everything to the 0 power is 1, 12. I'm trying to find one that's on the denominator. Let me just give you this example real quick. If you do have two, let's say 2 over x to the negative 5, the same rules apply. We do not want a negative denominator. I'm sorry, a negative exponent. Even if it's in the denominator, we don't want it. So it still does the same thing. It's going to take the reciprocal and flip to the other side. So it was on the denominator, it'll flip to the numerator and become positive. So that's the same as 2 times x to the 5th power. Okay, so it doesn't matter if it's a numerator or denominator, a negative exponent, basically take the reciprocal and flip it. Let's see, look, number 12. That's a different kind of question. What value of v is a to the v equal to 1? As long as a is not to 0? Well, the only thing that gives us 1 is to the 0 power, so it has v has to equal 0. That way, a to the 0 is equal to 1. What value of w is it if b to the negative w is equal to 1 over 9? Well, that would be negative 9. B to the negative 9 is 1 over b to the 9. Let's see. Okay. Again, most of those properties are self-explanatory. Let's go to the next one. So we did the product power. We did the quotient one. We did the negative and zero properties. There's one more important one. I mean, there might be more than this, but the important one for right now is going to be the power of a power one. So let's look at this one. When you take an exponent and raise it to another power, we call that a power to a power. And let's think real quick before we say it out loud. When we did the product powers, when we multiplied like bases, we added them. When we did the division one, a quotient one, we divided like bases, we subtracted the exponents. Well, the next kind is power to the power. When you take an exponent number and raise it to another power, you're actually going to end up just multiplying the exponents. So this one, 2 to the 2nd power raised to the 4th power, is going to end up being 2 to the 8th power. Let's see why it works real quick, because you have 4 of these 2 to the 2nd powers, 2 to the 2nd power, 2 to the 2nd power, times 2 to the 2nd power, times 2 to the 2nd power. You expand that out even more. You have 2 2's, 2 2's, 2 2's, 2 2's. And in total, you recollapse it, and it's going to be 8 of them. But again, the trick is multiply the exponents when you're raising a power to a power. So this one, 5 to the 5 times 3 would be 5 to the 15th. Remember, because you have 3 sets of 5 5s, and so it's going to be 15. You're going to have 4 sets of 3 x's, and so it's going to be x to the 3 times 4, which is going to be x to the 12th. Okay, and you can list all these out and see that's what the power products does. When you raise a power to another power, you're going to multiply the exponents. So let's look at this one. Use the power of the power product property to write x to the 6/5 to the raised to the 25th property? Well, that's going to be x to the 6/5 times 25. It's hard to make these 5, so I'm just doing that. Times 25. Well, 6/5 times 25. Well, 25 divided by 5 is 5. 6 times 5 is 30. That's going to end up being x to the 30th power. 6/5 times 25 is 30. Remember, you can just kind of cancel. Let's see, 25 divided by 5 is 5 times 6, 30. So let's look at these real quick. You have 2x raised to the 4th power. All right. Remember, the coefficient is not an exponent. You take it like a normal exponent. So you say like 2 to the 4th power. 2 times 2 times 2 times 2. All right, that's 4 times 4. That's 16. Although you can just leave it with an exponent right there, 2 to the 4th power. I might, as long as it doesn't get too big, I can just go ahead and write that out, 16. And then you say x, which is to the 1st power. 1 times 4 is 4. 16x to the 4. But again, you can leave the numbers with the exponents on them if they get too big to mentally calculate. And really anything after like 3 or 4th power, you probably can't do it in your head. I mean, I can't do some of those. If it's like 7 to the 30th power, no way can I do that in my head. I'm sorry. You have to use a calculator. Negative 4a to the 3rd power. Well, we'll take the negative 4 to the 3rd power first. Okay, that's negative 4 times negative 4, which is 16. 16 times negative 4 is negative 64. And then a to the 3rd power, well, a 1 times 3, because the exponent on this one, if we don't write it, you assume a 1, it's going to be a to the 3rd power. Now, going with what the book is writing, they might expect you to write like negative 4 to the 3rd power, a to the 3rd power like this. That would be another way to write this. I just happen to go ahead and calculate it out that negative 4 to the 3rd power is negative 64. All right, let's look at this one. X to the 3rd power, y to the 2nd power, to the raised to the 4th power. Well, that'll be x to the 3 times 4, which is x to the 12th. Y to the 2 times 4, which is y to the 8th. So x to the 12th, y to the 8th would be that one. And yes, that's probably supposed to go over here, but it's hard enough to draw these things with your finger on a mouse pad that they're just going to go everywhere. And so when you have the power of a product property for exponents and you just kind of want to write out the generic ones, you take that power and you put it on each one. It's sort of like the distributive property. I wish they had put different letters on here, because just writing m and m over this one, it doesn't take into account if there were exponents already on here. So not a good example in my thinking. Let's look at number 6. C to the 1/2, D to the 1/4, all of that raised to 8th power. Well, that's going to be C to the 1/2 times 8, D to the 1/4 times 8. 1/2 times 8, well, half of 8 is 4, so that's C to the 4th. 1/4 times 8, well, that's 2, so that'll be D squared. We're going to try again on number 8. X cubed over y to the 6th power, all of that raised to the 1/3 power. We'll just take each part individually. That'll be x third raised to the 1/3, which is going to be 3 times 1/3, which is 3 over 3, which is 1. So that'll be x to the 1st power, just x. divided by y to the 6th power raised to the 1/3. That's 6 times 1/3, 6/3, which is 2y squared. And so you just have to use this power to the power property along with the multiplication property and the division property and the zero and the negative property. If you put them all together, you can really simplify almost any kind of problem we have. Let's go down and look at real quick. Let's see this one. 2x squared y, all of that raised to the 3rd power, times negative 3x y to the 3rd power raised to the 2nd power. All right, well, order of operations, do what's in the parentheses, then take your exponents, then you multiply and divide, and then you add and subtract. So there's nothing we can really do in this parentheses right now, so we're going to go ahead to the exponent part. We're going to take all of this to the 3rd power. So that'll be 2 to the 3rd power, which is 8. Again, you could write just 2 to the 3rd power, but I'm just go ahead and calculate it in my head. X squared raised to the 3rd power, power to the power, multiply. 2 times 3 is 6, 8x to the 6. Y to the 3rd power, well, 1 times 3 is 3, so that's y to the 3rd power. Still got a multiplication right here. We've got 2 parentheses right next to each other, so I'll keep that in mind. I'm going to multiply that times this next one. Let's take this one and do the exponents. So let's do all the exponents first, then we do the multiplying order of operations. Negative 3 squared, well, negative 3 times negative 3 is 9. X to the raised to the 2nd power, well, that's 1 times 2 is 2, x squared. Y to the 3rd power raised to the 2nd power, multiply again your exponents when you're raising a power to a power, so that's 6, y to the 6. All right, finally, we still have like bases that we can combine. Now all we need to do is do the product property, which means when we're adding the exponents, because we're going to be multiplying like bases, we're going to add the exponents. Let's do the numbers first, though. 8 times 9 is 72. Remember, commutative property means I can do them in whatever order when all we're doing is multiplying. X to the 6th power times x to the 2nd power means 6 plus 2, x to the 8th. Y to the 3rd power times y to the 6th power means 3 plus 6, y to the 9th. So 72, x to the 8th, y to the 9th would be one of the answers that I'll accept on that kind of stuff. Okay, let's try C real quick. You have 4x over y cubed, all of that raised to the negative 2. Well, let's think about this real quick. Negative exponent means I need to take the reciprocal, so it'd be 1 over 4x over y cubed. All of that squared. Okay, the negative exponent, if we don't want to deal with negative exponents, we flip it over and make it positive. Well, now I will square everything, so that's would be 1 over 4 squared is 16. X to the 2nd power is going to be x squared. Y to the 3rd power raised to the 2nd power will be 3 times 2, y to the 6th. Okay, now, right now, you have a double fraction. Nobody wants to deal with double fractions. And so there is a way to get rid of double fractions, which is using your division of fractions rule. That's 1 divided by 16x squared over y to the 6th. And if you remember how to divide fractions, we don't like to divide fractions, so we do the keep, change method, where we keep the first number, change it to multiplying, and change the second one by taking the reciprocal, y to the 6th over 16x squared. And 1 times anything is just this number, so it's going to be y to the 6th, 16x squared. So basically, when you have a double fraction, just flip it over again. that's my easy rule to remember. A double fraction, you're going to have to flip it over again. Think of it like getting too top heavy. A boat capsizes when it's too much weight on one side, on the top. So y to the 6 over 16x squared. So let's see. Trying to think if there's anything in here that might be too much trouble that you couldn't try. 2/3 raised to the second power. Well, you just do each one individually. It'd be 2 squared over 3 squared, which is 4/9. 2/3 raised to the -2 power. Well, you would flip it over and it'd be 1 over 2/3 squared, which is going to be 1 over 4/9. And you don't want a double fraction, so it'd be, flip that over again, it'd be 9 over 4 for this one. 3x cubed, well, 3 cubed is going to be 3 times 3 times 3, 9 times 3, 27. X cubed, 1 times 3 is 3, so it's going to be 27x cubed. Okay, 3x to the -3, basically just going to flip it over to be 1 over 27 cubed. 2 to the 5th power raised to the 4th power. Remember, power to power, multiply to be 2 to the 20th. That would be 2 to the -20th, but then you need to flip it over, and so it'd be 1 over 2 to the 20th. So that's basically all the different rules on exponents. Okay, when you're multiplying like bases, add the exponents. When you're dividing like bases, subtract the exponents. When you're taking a power to a power, multiply the exponents. If the power is 0, the whole thing equals 1. And if it has a negative exponent, you just take the reciprocal and you can switch it over to positive. And real quick, just to make sure, 2x to the 0. All right. Remember, the exponent is only over this x. So that's x to the 0 power is 1. 2 times 1 is 2. So 2x to the 0 is actually just 2. Because anything to the 0 power is 1, but you still multiply by 2. So, all right. Hopefully that clears some things up. I know it was a little bit fast. We did do 3 lessons, but the rules of exponents sort of all go together. So did these lessons.